Okay, Chapter 3, Section 1, moving right along in Trig. We are finally going to start talking about radians and the unit circle. So radian is a unit of measurement used to measure an angle. So just like a degree, you also have a radian. When it comes to converting degrees and radians, 360 one time around the circle is equal to 2 pi. 180 degrees is technically 1/2 of 2 pi, so 1/2 times 2 pi is just pi. 1 degree is equal to pi over 180 radians, or 1 radian is equal to 180 over pi degrees. So when you go from degrees to radians, you multiply by pi over 180. And when you go from radians to degrees, you multiply by 180 over pi. That's how you convert between degrees and radians. So looking at example 1, we're going to be converting degrees to radians. So if I have 45 degrees, I'm going from degrees to radians. So 45 times pi over 180. Now I want you guys to go back to when you used to reduce fractions. So 45 and 180, 45 can become a 1, and 45 goes into 180 4 times. So we now have the fraction 1/4. So 1 times pi is pi, 4 times 1 is 4. So 45 degrees equals pi over 4 radians. And I always simplify writing radians by writing rad, because radians are rad. Okay, so if we're dealing with a negative number, same thing, negative 270 degrees. I'm going to multiply that by pi over 180. Again, you want to simplify that fraction. So 180 in this case is going to become a 2. 270 is going to become a 3. So it's going to equal negative 3 pi over 2 radians. And then you can just have a decimal degree, which again, you're just going to multiply by pi over 180. This time you get to use your calculator. 249.8 times pi divided by 180 is about 4.36 radians. So just a simple multiplication conversion. In example 2, we're going to be going from radians to degrees. So 9 pi over 4, to go from radians to degrees, I'm going to multiply by 180 over pi. So times 180 over pi. This time, I have a pi in the numerator, pi in the denominator. My pi's are going to cancel. I can go ahead and simplify as much as possible. So the 4 is going to become a 2. 180 is going to become a 90. 9 times 90 over 2 is going to give me 810 over 2, which will then equal 405 degrees. Same thing when it's negative. This is supposed to be a negative 5 pi over 6. I'm going to multiply by 180 over pi. I'm going to cancel out my pi's. My 6 is going to become a 1. 180 is going to become a 30. Negative 5 times 30 is going to give me negative 150 degrees. And lastly, if we had a decimal, I'm going to multiply by 180 over pi. This time we don't have a pi to cancel out, but we have a calculator. 4.25 times 180, all divided by pi, is about 243.5 degrees, or you can say 243 degrees and 30 minutes. Either one is acceptable. Lastly, we're going to talk about the unit circle. So I'm going to post this in the folder for this week, or I might just post it by itself so that you can always access it. You don't have to remember that it'll be in week 8, but it's going to be used from here on out in the class. So we have the unit circle. You can also find your own version at embeddedmath.com, but I will post a PDF of this for you guys. So we have our unit circle. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. It tells you what we already went over, what functions, what trig functions are positive and what trig functions are negative in each quadrant. It also tells you our main exact values, 30, 45, 60, and we also have 0 and 90. Our quadrantal angles of 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then 360. And then on the outside, it tells you the radians of that degree measure. So if it's an exact value, it has an exact radian. And then we will talk about these at a later date. Actually, we'll talk about them in example 3. So each of these are your XY points on the circle. So for 30 degrees, you got square root of 3 over 2 and 1/2. Those should look familiar because the cosine of 30 degrees is the square root of 3 over 2. The sine of 30 degrees is 1/2. So even though that they look like XY, cosine represents your X value, sine represents your Y value. So going around, we start here at 0, you go 0, 1, 2, 3, and then you go 1, 2, 3, 0. So 0, 1, 2, 3 in your Y's, and then 0, 1, 2, 3 down, starting up here in your X's. Everything gets a square root, but the square root of 1 is 1, so everything has a square root, no square roots on the denominator. Okay. Example 3. We're going to use the unit circle. We want to find the function value. So I want to find the tangent value of 2 pi over 3. So I'm going to look here on my unit circle, and I'm going to look around till I find 2 pi over 3. So 2 pi over 3 is technically 120 degrees. So the tangent of 120 degrees is what we were actually looking for. We can use our exact value table, and the reference angle, theta prime, is going to equal 180 minus 120, what we did back in chapter 2. So my reference angle is 60 degrees. So if I look on that little chart, the tangent of 120, or in this case 2 pi over 3 because we're in radians, is negative square root of 3. Technically the tangent of 60 degrees is the square root of 3, but since we are in the second quadrant, tangent is negative in the second quadrant, so it is negative square root of 3. Part B, the sine of 3 pi over 2. So again, look on your unit circle. 3 pi over 2 is down here at 270 degrees. So like I said, cosine value, sine value. Wants to know the sine of 3 pi over 2. Cosine, sine. The sine of 3 pi over 2 is negative 1. Last but not least, we have the cosine of negative 4 pi over 3. So since it's negative, instead of going this way, we're technically going this way. That's all it's doing, is telling us what direction we're going. So negative 4 pi over 3 is technically negative 240 degrees. So the cosine of negative 240 degrees. Technically, we're going to pull that negative sign out. Reference angle of 240 is 60. So negative cosine of 60 degrees. So you can look right here. The cosine of 60 is 1/2. Since we are in technically the third quadrant, our answer is negative 1/2. And that will equal the cosine of negative 4 pi over 3. And that is it for section 1. So just a lot of multiplication, reducing fractions, and then just looking at the unit circle. This, along with any note cards, is going to be your lifesaver in this class.